Awesome. Hey, everyone. Super excited to welcome you to another amazing session. My name is Aparna, one of the founders here at Arize. And today we're lucky to have the founder of LangChain here with us to do a little fireside chat. Harrison, would you mind introducing yourself?
Absolutely. Thanks for having me, by the way. Excited to be here. My name's Harrison. I'm the co-founder and CEO of LangChain, which is now a company, which is founded around the open source packages called LangChain that are used for developing language model applications.
Awesome. And you know, the GitHub repo is so popular that everyone's probably heard of it, but just in case for new folks who haven't yet heard of LangChain, could you walk maybe us through a little bit of why did you decide to build LangChain? What is LangChain used for? Agents, like what is that? It's so popular right now. Yeah, could you just walk us through a little bit of that journey for you?
Yeah, absolutely. So LangChain is a framework for developing language model applications, and we started off as a Python package, and now we have a TypeScript package as well. And so what exactly does a framework for developing language model applications mean? I'd say there's two main components, and both of them came from the same. Both of them had the same origin story, which was I was talking with a bunch of friends who were building stuff in the space. I saw a lot of kind of like repeated patterns that they were doing, and I decided to like factor those out and put those in kind of like an open source Python package at the time. And so a lot of those like patterns fall into kind of like two categories, and these are like the two major value props of LangChain that I see. One is like the individual kind of like components for everything that makes up these really like applications that are based around language models. So at the center you've got like language models themselves, but then you've got other types of models as well, like chat models and embedding models, and then you've got prompts, which are now these new ways of programming them. You've now got these vector stores, which are very important for memory. You've got a lot of utilities for loading documents, chunking documents, stuff like that. And so I saw basically everyone was using these components, but they were slightly different. Maybe they were using like a Cohere model versus an OpenAI model versus a Hugging Face model. And so what we've added is a lot of like standard kind of like interfaces for all these different components. So you can easily kind of like swap between them. And then we also have a bunch of like integrations / implementations depending on the components. So for like language models, like we integrate with a bunch of things. For document loaders, we have a bunch of implementations ourselves. So it kind of depends on those, but basically we have all these components, standard interface, lots of integrations or implementations. The other value prop and the other thing that's in LangChain is kind of like a way of taking these components and treating them like Lego blocks and building up to more complex kind of like chains. And so chains are basically they're assembling these components to do specific things. So for example, we have like a question answering chain, which first there's like an ingestion step, and that uses document loaders to load documents, text splitters to split the documents, embeddings models to create embeddings, vector stores to store them, and then it's got a prompt that does a retrieval step to this embedding store, puts the retrieved documents in the prompt, calls the language model, gets back an answer. And so it's basically this sequence of things. And so there's a lot of these different sequences. A lot of the more popular ones kind of had two flavors. One was like connecting to external data sources. So I saw a lot of people doing kind of like chat with your documents, chat with your SQL tables, stuff like that. So we have a lot of those types of chains. And then the other flavor that I saw was a lot of what I would call like agentic chains. And so these are chains that use the language model as a reasoning engine to decide actually what to do. So rather than hard code specific, like do A, then B, then C, then D, you let the language model choose what order to do things in. And this is really useful because, I mean, even if you take a simple example, like conversing with a SQL table, there's a simple chain where you take a human question, convert it to a SQL query, run that against the table, get back an answer, convert that back in. But what if the query's wrong and incorrect and raises an error? What do you do then? What if you need to make multiple queries? And so I think chains are a really good place to get started because they're a predetermined sequence of steps. So they're easy to understand, they're easy to reason about. But when you want to do complex things like recover from errors, or handle kind of like more complex tasks, that's when kind of like agents come in. And a lot of the initial things that I saw people doing had some flavor of both of these. And so a lot of the chains and agents and LangChain are really centered around those two ideas.
That is super, super helpful context. You know, outside of, I guess, outside of where you see the usage happening today, which is, connecting them for more of these question answer or chatbot type of experiences and chaining together prompts. Where do you see, I mean, this last week has been insane for autonomous agents and kind of the agent simulations and all of that. Where do you see kind of, maybe help break it down? Where's kind of the world of today, like the use cases that you feel like most people are going to use agents for today? And then where could it go with, sci-fi style, or even just like, 6 months, that's where we're at. That's how fast the space is moving. But 6 months out, like, where do you see kind of more of these autonomous agent trends going?
Yeah, I mean, I think today a lot of the a lot of the agents, unless they're really narrow focused, are kind of like more cool Twitter demos than anything else, to be honest. I think they work in some cases, they don't work in other cases, they kind of go off the rails a bunch. I think it is possible to have very focused agents for specific use cases today. And so I think but I think that requires like really, really good prompt engineering of the prompts, really careful selection of the tools, and there's a good kind of like agent executor or something like that. And so I think I've seen like good examples of that. Like really, there's one that's like, I think focused on kind of like code execution that's decently well done. There's a few that are focused on kind of like retrieval. So retrieval you can do in a standard way, or you can use an agent to do it. And so I think that's a bit more practical today. And then there's other ones, again, around the idea of like giving it a very limited set of tools, a very carefully selected prompt. I think what we'll start to see
Actually, just double clicking on the retrieval one, could you explain just, what's the advantages of someone wrapping it in in an agent versus just calling it directly? Like, what do you see the pros cons there?
I think the agent just allows for handling of like more edge cases. So if you think about like a typical retrieval pipeline, like you get a question that comes in, you retrieve the relevant documents by doing like similarity search in the vector store, you put those into the context and you pass that back to the model. But, like there's one that kind of like hard codes what retrieval mechanism you're using. And so it could be the case that you might want to do different types of retrieval based on the query that comes in. And so specifically one idea that like we're playing around with is like, adding kind of like filters to the metadata based on the query. And then once you do that, like you can do that and you can hard code that. But then what if you add like too stringent of filters and they like break, or they return 0 documents? What do you do then? And so I think having the and similarly, like maybe the user question comes in, but you don't want to look up the whole user query. You only want to look up like selected terms, or you want to do like multiple lookups. And so basically like having, just like when we do retrieval of documents, it's a really complex process. And so like maybe like similarity search covers like 60% or 80% or something like that. But there's a lot of edge cases it doesn't. And so it's basically like, yeah, taking care of the long tail of edge cases there.
Got it. Okay, that makes sense. And you were headed towards where do you see this going?
Yes. So I think there's probably like 2 places where it's going. One is like more generic tool usage. So having, humans are pretty good, like 0-shot learners, and that we can like get some instruction and figure out how to do it. And so like, I think having agents better at that, and kind of tied into that, although maybe also separate, I think the idea of like long-term memory is really interesting. So having agents that, and you start to see this with one of the papers that came out this week, which is a bit before the event since we're recording, but is the generative agents or Westworld paper. And that had a really interesting long-term memory system that did some like time-weighted and importance-weighted retrieval step. So already you've got a much more complex retrieval system than just semantic search. And then on top of that, it added in a reflection step, which basically, like to simulate how our memory kind of like works, like we don't remember every single event that happens unless you've got a really good memory, but we kind of like build up some intuition for like over time, like, I don't like the taste of tomatoes or something like that, rather than, oh, I had tomato at time X, tomato at time Y, tomato at time Z, and I didn't like the taste of it. We kind of like condense that into information. And so I think that's a really interesting step in this idea of like more long-term memory that learns. And so I think we'll start to see more of that as well.
Super interesting. Well, of course, there's also that use case that, of course, we're both excited about, which is around LLM, assisted evaluation and using agents to be able to do that. Could you talk a little bit about that and kind of where you see that going?
Yeah, I think the idea, I think there's a big pain point that this is solving, which is like for all these generative applications, it's really hard to evaluate them. And that's because these aren't producing like a single number that you can do like MSE on or accuracy or something like that. You've now got like these, at the very least, you've got like a natural language response. You've also possibly got some like intermediate steps that an agent has taken or something like that. And so there's some heuristics you can do there, like, you can have some ground truth. And for like the intermediate steps, like, like, did they line up to the ground truth? But there's more than one way of doing things, right? And so like, and for final answers, there's definitely more than one way, right? More than one way of expressing a correct final answer. And so, the way to do this up until now has been to ask humans to kind of like evaluate it. Like, is this answer correct? Like just like a teacher grading like quizzes or tests or something. But now these language models are really good and they're starting to approximate humans in a lot of tasks. And so why not use them to approximate evaluation? And so I think that's an area that, we're both extremely excited about. I think is getting more and more feasible. There's been a lot of really cool research by folks at like OpenAI and Anthropic around doing this in pretty complex ways. I think not only is it a cool research topic, but it's very like applied and very practical because again, there's no really great way to evaluate these things.
Yep. And I think part of the reason why we're, we have that integration out between Arize and LangChain, for instance, to be able to, log all of those, let's say LLM assisted evaluations, use agents to call them, and then log all of them to visualize and troubleshoot and do that kind of hand in hand.
Yeah, and I think like the going back to agents for a second and why they're not kind of like used more widely or why they're not production ready is because it's really hard to understand what's going on inside them. And so I think integrations like the Arize LangChain one are really helpful for that because they help kind of like shine a flashlight into that dark thing. And there's a lot of different things that you might want to look at, like the different steps, the kind of like inputs and outputs in their space or their position in the embedding space and stuff like that. And so I think it's the overhang for putting these things in production isn't really for most cases. I don't really think it's latency for most cases. I think it's more just like these things aren't good enough and they're not good enough because it's hard to debug them and hard to get them ready. And so, I think integrations like the Arize LangChain one are really helpful for that.
Awesome. Yeah, that's actually my next question is like, how does observability around agents, I know we've been kind of thinking about, okay, what are the required components? Every single part of the chain gets logged. But yeah, how do you think about troubleshooting agents, or have you seen any users kind of hit any bumps, and how have you seen, what are the ways you've seen them fix those problems?
Yeah, I think the main way that I've seen, and it's not going to be super, sorry for my calendar going off. The main way that I've seen it is not super satisfying, but I think it's quite good is just looking at the inputs and outputs. And I remember talking to someone a few months ago who's been building with language models for at least a year, if not like more than that. And I asked him what they did for evaluation and whether they had any metrics. And he was like, no, I just like look at them. And that's totally fine with me. I've built up an intuition for what's going on, for what works and doesn't work. Maybe, and I think I am very bullish on LLM assisted evaluation, to be clear. But I also think that in the short term, there is no substitute for just like looking at the inputs and outputs and building up an intuition. And so even if shining the flashlight just means logging those and looking at those, I think that's good enough.
Yep. It's like the table stakes to move forward.
Exactly.
Even get to the next stage. Yeah, agree. Okay, I'm going to change gears a little bit here. Space is moving super fast, so your answer might be outdated in a week. But any differences you would comment around kind of the React style approaches to task controllers versus maybe like a Baby AGI style of controller that does the outer loop of task optimization. Like anything you would comment there?
Yeah, I think there's and I just wrote a blog post on this, so it's very top of mind. I think there's okay, so I think one of the major differences that causes some of the smaller differences is in kind of the tasks that they're asked to execute. So a lot of the React style agents are more like focused on like answering specific questions where maybe there's like one or two or three or four tool lookups, maybe max, but they're kind of like very focused in their objectives. The Baby AGI and Auto GPT things are much more open-ended. It's like increase my like wealth or something like that, right? It's not like a question answer. It's kind of like a long-running thing. And so I think that leads to like two differences that I noticed. So both Baby AGI and Auto GPT do something that the LangChain React agents don't, which is they do more kind of like clever and long-term memorization of intermediate steps. So the React agents with the intermediate steps, they just keep a buffer of those in memory, or they just keep a list of those in memory, and they always put that in. But as soon as you start doing a lot of steps, that'll overflow the context window. That hasn't really been an issue, again, because of the difference in objectives, but that would be an issue for the Auto GPT and Baby AGI thing. And so they use this concept of long-term memory, which we have in LangChain, but mostly for like human to AI interactions. They use that for AI to tool interactions. And so they have that as a separate component. And then the second thing, which is actually, I think only Baby AGI does this, and I think this is a little bit what you were getting at. They have a distinct kind of like planning and execution step, where first they list out like five, like however many tasks they want to do. Then they pick the first one, they go execute it, they get an observation, they come back, and then they update their task list. If you compare this to the React style thing, the React thing thinks about what to do, one step, then does it, and then think about the next thing, and then does it. And I think this, and I think the difference is again due to the objectives. Like React styles objectives are more focused and more kind of like directed, so you can kind of do that one at a time thing. The Baby AGI thing is much more open-ended, so it's really helpful to separate it out, keep a memory of it, not forget about it, and kind of like guide it in the long-term course.
Got it. And I'm just, as you're talking, I'm like, wow, the concept of troubleshooting the more complex Baby AGI style is going to be way harder than just the hard coded React style type of controllers. But also super interesting what different types of problems each one of them may run into.
Yeah, no, I think I think there, I mean, and there's different. The thing that I like a lot about the Baby AGI and Auto GPT, just at like a personal level, is like the interface isn't really chat anymore. It's some like interesting thing where there is human in the loop feedback, and you can like yes, no certain actions. But like, I mean, there's been a lot of chat about different UIs, and everything's kind of come to chat at the moment. But there's got to be something else, right? And so that's what I like about the Baby AGI and Auto GPT from, again, purely just like, just like personal level.
Well, I think it's okay. It's the great actually segue into my very last question with you, which is, what industries do you think agents will have the largest impact or most immediate impact in terms of deploy, and where it will actually be deployed and used? Do you think it's likely to create industries we don't even have yet today? Open-ended, but would love your take on it.
I mean, maybe my hottest take here is that everything that is like API call or a chain should really be an agent. And again, going back to just the ability to handle errors, to kind of like handle edge cases, to handle multi-step things, like everything that we think of as like an API or chain should really be an agent. And that's probably my hottest take there. I think in terms of like specific industries, like I do think there will be a lot of existing kind of like players that can adapt and use these pretty easily and get started with them. And I think that's a lot of the power of the foundation models that are coming out. And I think it's pretty much like every industry. I don't know if there's like any in particular. I think, I mean, definitely ones where there are like a lot of text are like the primary ones to start. So you saw a lot of like companies focused on like marketing pop up. And then I think like there's starting to be more around like legal and stuff like that, because there's a large concentration of textual documents, which are good. But I think RPA is a really interesting one. This gets very closely tied into agents and approximating that. So, but at the end of the day, like if you think about it, I think there are probably areas of most industries where humans do kind of like rote or routine things that could be approximated by agents. And I think we'll start to see more and more of that.
Awesome. 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 Well, Harrison, thank you so much for being a part of Arize Observe. I feel like I personally learned a lot, and I'm sure folks in the audience probably, really appreciated just how in depth a lot of your answers and kind of your takes were, and even your hot takes. So really appreciate you kind of being on this. Any last words for the crew here?
No, I really appreciate you guys having me. I really appreciate the Arize LangChain integration. I know that got shown off yesterday or something like that, but I really do think that like obviously I love agents, right? And obviously they're not in production yet. And I think a lot of that is due to the fact that it's really hard to build them, and there is troubleshooting and kind of like fixing and observability that's needed. And so I think the integration is awesome. And yeah, really appreciate the fact that it's in there.
Awesome. Well, thank you so much. And looking forward, everyone else, to the next session we have coming up at Observe.